Uh, Very good morning to dear participants. Welcome to session 11 of this mixed signal design FDP, STTP. Today's session resource person is Mr. Pradeep, who is working as senior application engineer at Apply Volt. He did his BTech, MTech under the University of JNTU, Kakinada. He has worked in Xeon Semiconductors and then Tenet industry. He has industrial experience also, and he is widely participating in training sessions as a resource person at various institutes across the country, like IIT Bhubaneswar, NIT AP, NIT Raipur. His profile is rich of experimental knowledge, practical knowledge, working with FPGAs in RTL design, back-end design methodologies. So, welcome, sir. Pradeep, sir. Pradeep, sir. Pradeep garu. Pradeep garu. Sir, Pradeep garu.
Sir, Pradeep, sir.
హలో
ప్రదీప్ గారు సార్ వినపడుతుంది
సార్ వాయిస్ అనిపిస్తుంది సార్ మీ వాయిస్ నాకు అనిపిస్తుంది మీ వాయిస్ నా వాయిస్ మీకు వినిపిస్తుందా సార్
ఎస్ సార్ వినపడుతుంది మీరు స్క్రీన్ షేర్ చేసి
స్టార్ట్ చేయండి సార్
నేను ఆల్రెడీ స్క్రీన్ షేర్ చేశాను సార్
అది తర్వాత నేను మళ్ళీ
స్క్రీన్ షేర్ ఆల్రెడీ చేశాను సార్ గివ్ ద కంట్రోల్ సార్ ఒక నిమిషం స్టాప్ చేసి
మళ్ళీ
స్క్రీన్ షేర్ నేను చేస్తాను ఇప్పుడు వచ్చిందా సార్
వస్తుంది ఒక నిమిషం
రైట్
ప్రెజెంటేషన్ మోడ్ పెట్టి స్టార్ట్ చేయండి సార్ ఇంకా
ప్రెజెంటేషన్ మోడ్ లోనే ఉంది సార్
వచ్చేసింది ఓకే యూ కెన్ స్టార్ట్ సార్
ఓకే సార్
ఓకే థ్యాంక్ యూ సార్ యూ కెన్ స్టార్ట్
very good morning participants who are attending for this mixed signal analog mixed signal module design. Today we are discussing about AICTE design flow in this what are the importance in analog mixed signal design, because while you are considering the analog part, you can also consider the digital part in some point of your time, because the integration of ICs are manufactured in terms of different technology files. Okay, so based on those designs and circuit level description, we are seeing today on the some EDA tool solutions. So based on that, we are going for the Mentor graphics design tool set. Coming to that, we know that so this is our equation for the basic defined equation for IDS. Okay, the current from source to drain for a common CMOS or MOS transistor for PMOS transistor or NMOS transistor, where you want to identify that. In this equation, we are mostly concentrating on the different scenarios W by L, that means aspect ratio. We can vary the length and width of that ratio, where here the length is nothing but our technology part, which is defined by the foundry persons, and we also vary the different voltage ratings according to VDD, VGS, VDS. So these different voltages also we can vary by manually, but we can't vary that conditions like COX, oxide layers, capacitive oxide layer and C load, because C load is nothing but C load is always consisting of the overall capacitance of the transistor. The transistor can consisting of a different of around 3, randomly you can consider as from gate to drain, gate to source, source to drain. These 3 capacitance you can calculate, it means those capacitance is nothing but a C load. So the second equation is we can consider as a power condition, power equation, which is respect to the frequency, and that means the time response of the clock signal. Response of the clock signal. Okay, so based on that, the transistor looks like this in the physical representation and layout representation and RCA modeling file. Modeling files, we can see that, but right now I'm going very fast because already it takes some delay, so I'm going somewhat fast. Okay, so basically this is the VLSI design modeling styles. We are consisting of different styles of ASICs. Those are nothing but semi-custom flow and full custom design flow. Today we are discussing in this full custom design flow because we are always concentrating purely on analog modeling. So, okay, mixed signal. That is the reason I'm only concentrating on full custom design. The design consisting of initially the design consisting of the specifications to identify what type of requirements you think. For example, the requirements like what is the length of the transistor, or how much of the size of the design, area point of view, delay point of view, power point of view. You want to identify within low constraints or high constraints, and aspect ratio, signal to noise margin. These things you want to identify in your brain, and you want to specify the specification while you are designing the entire circuit. So these specifications has been you can connected and calculated, and you can restructure the entire circuit by using some EDA tool. So those tools, in that tools you want to insert according to the aspect ratio of your part. Aspect ratio means W by L. According to that you can give and you can utilize, because you can, by using W by L, you can design so many things like GM, RL. Okay, these are the signal to noise ratio, margin, and after that designing these color after the circuit, your design, you can design taking a differential amplifier while you are connecting all the transistors and making a circuit. After enter the circuit, you want to simulate by using a simulator. By is called, if the simulator is if the results is you are satisfied with those results, then you can directly go for the layout. Otherwise, you want to again reconnect the layout, and you can again you can reconnect your circuit to reach your accurate point of simulations. After that only you can easily construct your layout. After layout, you want to go for the physical verification like DRC and LVS. These are the DRC means design rule check. These design rule check is also defined by the foundry persons. So here we are using a tool name called Caliber, one of the greatest tool in the industry point of view. So by using this caliber tool, we can easily identify the DRC, LVS, PEGs, parasitic extraction. Okay, so by using these things, we can easily enhance what type of defaults or what type of errors is existing in your design of your layout. So if you are satisfied with your all these three verification parts like DSA, LVS and parasitic extraction, then you can go for the post layout simulation for the identification of the how much delay and how much time differentiation is happening in the layouts part, because when you are drawing your layout, what you are identifying, you are draw the layout in terms of material point of view. It is not in terms of wire, it is in terms of metal 1, metal 2, poly, silicon. Okay, these terms of materials has been there. For each material there is some sort of resistive element and some sort of capacitive elements, which is observed by in the previous step is uh, parasitics. In the parasitics we are observing these scenarios. So what is the resistance and capacitance are doing the factor means, resistance is resist the voltages or flow of electrons, as well as the capacitance is to store the device, store the voltage ratings and electrons. So what is happening while it is storing and resisting means, then the flow of the control, for example you are giving the 5 volts of voltage, you are expecting the 5 volts, but you are getting certainly as a 1 as a 4.5 or 4 volts, then the sort of 1.5 1 volt or 0.5 volts has been opposed or stored inside the internal part of the material that is existing in the layout, or observed by in terms of parasitics, So for that parasitics, what we want to do, if you are thinking still it is not appropriate or not actually getting into the design point of view, then we want to redesign your layout for the actuals in some lambda based rules for the distance to distance, and to optimize your design. Okay, to optimize your right. So after this post layout simulation, you can go for the padding tape out. So this is the specifications for the graphics. In this we are using for the entity design for the Pixis editor. Pixis editor, schematic editor, and functional verification is for Aldo simulator, and waveform is used, and for the layout we are using for the physical verification. Again, we are using caliber. For the post layout verification, we are using again Aldo simulator. These are the tools we are looking into this. So now what I want to do is I want to go for my layout window. Here I am using the open terminal, and I'm using commands also. I'm increasing that commands. So first command is CSH, that means clear shell, and the second command we are using here, it is source. Okay, source/home software mentor graphics CSHRC files. You are using the file for all CSHRC, which is actually located in home source home located where the CSHRC is, and press enter. Then want you to ampersand. Okay, I'm using the design enter okay, ampersand means administrative rights. I'm giving enter. Now the Pixis environmental window has been pop up. Now the Pixis environmental window has been pop up. So here in the project navigating window, you can navigate all your projects. So it's loading. Please start the design. So go to the file, new project. There is a file, new project. Here you can give your location. Okay. Images analog and project folder, one empty new folder, new directory folder. In the directory I'm giving some name is called AMSD. Okay, SMD, and this is my project name. My project name is AMSD, analog mixed signal design, and I want my targeted library files. For that I'm going to browse. I'm taking that targeted library file from home software. Actually we can observe that where is CSHRC file, home software mentor graphics. So in that mentor graphics only there is a one folder name called Foundry. In the GDK Pixis setup, IC reference library, IC tech library, and generic 13. So the path is like this. Okay, this is the path. You can identify that. Can zoom out this one. So you see part. Again, I'm highlighting the part where the path of technology files are located. Software, mentor graphics, foundry. The foundry there is a GDK general kit is there. In the kit we are having Pixie setup help HTTP means higher education program. In that IC references libraries are there. Okay, in that library I'm having tech libraries, technology libraries. Tech means technology libraries. In that technology library I'm selecting generic 13. Generic 13 you can select and click OK. So you can observe the configuration of the it's showing means it's showing that DRC, LVS, specs, optimization, every type of processing files has been displayed. So here there is asking any libraries are exist we can add. So we are adding standard libraries. Already two types of libraries are added. Now again click on browse. And click on browse on icon there is a browse location map. In that out of 5 to 6 6 to 7 already analog EMS is simulator is already added, analog simulator is added, and OA is optimal is added. You want to add device library, you want to add generic library, you want to add source library, you want to add something like Verilog or macros. Okay, but mostly Verilog you can use. If you want to use, you can use, but Verilog is for the useful for the semi-custom design flow. Semi-custom design flow, but we are always concentrating on full custom design flow. Very good. So after adding these libraries, existing libraries, just click OK. So you can in so I want to use my manual library. Manual library means I want to create my own library. These are already existing libraries. I'm not disturbing any library there. So right click new library. So the library name is VLSI. I'm giving as a library name as VLSI. Okay. In that library, I want to create new cell. Any manual library can create a number of designs. Those designs come format schematic format. Forms and schematics. So is the new cell. I want to something like something like differential amplifier. I can go for DFS, differential amplifier. So in that for differential amplifier, I want to create new schematic. First, I want to create the schematic. Later, create a symbol. Later, I want to create the layer. First, I am going to the schematic. So, if you want to change, you can change your name. Otherwise, you can click name of my schematic right now. If you want to change, you can change, but don't allow spaces. But don't allow any spaces. It leads an error. So this is my schematic editor, that is Pixie schematic editor, what I have mentioned in my PPT. So here transistors. I want to place the transistor PMOS as well as PMOS transistor as well as NMOS transistor. Okay. So add instance. You can go for add
go for an icon, add instance. Here you can select your generic 13. In that symbols there is a PMOS and NMOS transistors are there. PMOS and NMOS transistors are there. From that transistor, for zoom in and zoom out, you can mouse scroll bar. I require true transistor, PMOS and NMOS. If you want to change any polarities like width and length in the window, editor. So I already enabled the object editor. In this object editor, I am changing my width as 0 point something. I think I can go for 0.3. 0.3 as my width. If I want to rotate this transistor, select, right click, flip horizontal. I want to flip the design. Okay. Now I want to go for add instance again. This time I want to take in the generic 13 symbols. I want to take NMOS. I want to take an NMOS transistor. And I want to change the width of the NMOS transistor. My NMOS I am changing aspect ratio of NMOS. So I want to flip the horizontal axis also. So this is my design. Now I want to make the connections. Go to add, click on wire. You can have the wire connections are available. These are making here. These are the input terminals for the taking input terminals. These are the connections. So now I want to give the input port. Here the name called add. Add to node, and you can click on import. If this is your negative, you can rewrite the design of nodes, like you can select the node, input node, VP and VN, positive and negative, as well as you can take your input because this input is used for I referral. Because I want to give the current image here, okay, current source I want to give in here. From the current source I want to see the outcomes. So I want to change the output. So this is my output. The output, what is the name of the output? You can give V out. And what are the remaining things is left? VDD and ground. So going to the add, you can take the ground node as well as VDD node. From the general library, you can take ground node as well as VDD. So after all the connections, generate your number. Before that, you can say, is there any error? So there is no error. Check the or generate, go to add, generate symbol, go to add, generate symbol. From that you can click on replace existing symbol. This is an amplifier, differential amplifier. You can go for a buffer node also, no issues, or you can go to the box and you can click on OK. I'm taking as a box and in customized pins, what I'm doing is bottom. Bottom, results are left and outputs are right. Then click OK and push OK. This is my symbol. So after generating the symbol is right, then I'm closing this schematic window and again in my library, manual library, right click new cell. This cell is test bench of my differential amplifier. So here clicking on OK. Test bench. You can the name of schematic and given as schematic 1 for differentiation between the actual schematic and the test bench schematic. So instance, from this instance, go to your manual library, that is VLSI. In that you can select your differential amplifier and place and now you want to go to so I'm taking the nodes also, input node and output node. You can give the input node and output node. You can give the same name or different name, doesn't matter. You can give the same name or different name, it doesn't matter. So now I want to identify my biased voltage. Okay. So what I want to do is from the source library, from add instance, in the source library, I'm going to DC source. I'm giving the DC source as one word. Also giving some current source, and I want to make the connections. Now I am going to give the VDD and ground from generic library. I am not changing any variations in this voltage. Maybe I want to change only the 3.3 volts here, the maximum I am giving here. 3.3 volts. Rest of the thing is 1 volt I am putting, and amplifier also I am not changing here current in terms of amps. So what I want to do is, I can say, then I am going for the context. In this context, there is an enter into the simulation mode is there. Entering into the simulation mode is there. Click on entering into the simulation mode. In this window, click on new design configurations. In this new design configuration, I have to identify the design operator OP. Click OK. Now I entered into the mode. I entered into the simulation mode. So what I want to do is, I'm going for the setup simulation, and here enable OP as well as take the maybe required or not required. I mean, DC is not required. I want to go to the AC. Something like how much of frequency it is some 100 you can take, and you can click on apply, as well as I'm right now I'm giving as my transient time analysis. Going to 5T. Okay, transient analysis. The start time is 0, stop time is some 1000 nano, and print time, every print time interval is 5 nanoseconds. Every 5 nanoseconds it must be printed in our screen the waveform, and I also given that my analog AC analysis, the starting 100 and it is in terms of 10. So now I want to click on OK and apply. So here the log simulation analysis has been done. Yes, it is running. Yes, it is finished. Now, in this window, we can observe that there is an DC OP tan analysis is there. So you can click on OP here.
Okay, operating point you can observe, you can see here. Still the OP window is not opening, I think so. I want to queue analysis operating point. Yes. Go into the outputs, currents and potential currents. Here I am giving this inputs and output. Open to prompt. Magnitude. You can change that. What is going on? So you can take the phase margin magnitude. You can take magnitude in dB. We can change magnitude. Apply. This is for AC analysis, and you can and plot. Okay, and run. You can see some. You can see that. Okay, some error is there. What is the error? You want to see error. No voltage nor current AC source is specified. Okay, there is no AC source is specified. There is identified that. So what you want to do? You want to end the simulation, exit the simulation, and you want to give some AC source. So you can give AC source as. Before the AC source, I want to go for the DC analysis. So now here there is no error because I am looking for the OP operating point. So there is no error. So I want to give OP. So OP of what you want to identify for different transistors. You can select the transistors, individual transistors, and after selecting all the transistors, move here what type of first transistor located in saturation, second is also located in saturation. So 4 transistors are located in saturation. You can observe that transistors are located in saturation. And what are the differentiations is the existing, everything is accurate, the same voltages we are given, that's why it is everything is in the same node and same analysis. These are the different types of readings and voltage at same for the P transistors as well as whatever advanced transistors you can see. You can try this one and you can identify, and is also same, identify in terms of same or not, you can easily identify. So yes, NMOS is also same. So what you are identifying is all the 4 transistors are existed in saturation mode. Now what do you want to do? We want to do rest of the design by close and ending the. So now I want to give the analog sine waveforms. So go to the source now. V source, sine AC V source. Sine AC V source. Sine AC V source, it will give you the information like what are the we are having, the frequency is there, amplitude is there, magnitude is there. So you want to change here sine AC V source. The amplitude voltage is 3.3. You can take it as voltage as 3.3, and frequency as I'm taking a frequency something like 100 mega. Magnitude is 1. Magnitude 1. Offset is also the same. The same readings also I'm taking here, 3.3 and 100 mega. If you want to change, you can change, doesn't matter here. So now I want to place, click and OK. There is no errors, very good. Now I want to go for context, enter into simulation mode. So you can click on here. Now enable AC and click OK. Continue the simulation mode. Then you can identify is there or not. No error. The simulation is properly completed. Current simulation is completed and view waveform. This is so here we some is in current analog form, another is in this is for your transient analysis. So this is for the transient analysis. You can identify these two are in the same phase. Okay. The phase difference is differentiation is happening. this differentiation is happened here. And okay, for coming to the analog part, what I want to do is to take the analog. In that I want to open only outputs. So there is a differentiation between the magnitude dB, magnitude and magnitude. So here what is happened is there is no still not changes is there. So what I want to do, I want to change the timing difference. Then I means that I want to increase my frequency. There may be change in the differentiation. So what I want to do, I want to close the simulation window and I want to enter simulator. So now I want to change these to something 500 magnitude response as well as in that setup AC something like here also 500 I can put or 1000 I can make as 1T. Apply, okay, continue. And now you can use that here for ESC plot dB, plot magnitude, plot phase. So these are the differentiation you can do here. So like this, we can easily identify the magnitude, response, and phase of our analog part. Okay. If you are on to see the transition, we are not bothering about our DC analysis, but you can see the DC analysis output also. Okay. Now I'm closing my simulation window. What I want to do, I want to draw the layout for my actual design. So I'm closing my simulation window, going to the design of my differential amplifier, right click and click on layout. So the layout cell and layout name as well as cell name must be equal. Layout name and cell must be equal.
Okay. Now, by using an SDL means schematic driven layout. The tool name is called SDL, is schematic driven layout. From the schematic, you want to draw the entire layout. From the schematic, you want to draw the entire layout. So click on your PMAS. Select the PMAS. So I'm PMAS. Actually, while you are clicking on pick and place, what will happen? It will show the first node is this one, the first box. This is the source terminal, followed by gate node, followed by drain. So gate, drain. So what I want to do, actually I am having the source is gate, another is drain. So source is connected to where? Source is another source of mass. So for that case, select the PMOS transistor, right, edit, flip horizontal. Dimension has been changed, horizontal of the virtual line. This is the virtual line of horizontal is flipped. Now what I want to do, I want to take the another PMOS. Now pick and place. I was directly want to insert in between these two blocks. I want with my white. So what happened? It is automatically attached. Very good. So similarly, I want to do the same thing for NMOS. Same thing for NMOS. So here what will happen? The source is also common. Here also the source terminal is also common. NMOS. You can put this source. Here also the same thing. First one source, next one gate, and the next one is drain. With horizontal. Similarly, I want to take this one. Pick and place. I want to directly. You can observe that straight line is happening. According to the straight line, you can place here. Now all the three factors has been done. Now what I want to do, I want to rearrange the layout by using, select the layout part and press M in your keyboard. Select the layout part and press M in your keyboard, then it will move automatically according to your the position. You can place. You can identify randomly and press it. After that, I am going for the device, add devices. The device name is $GB_P. In that P, I am having P substrate is for NMOS transistor. So I am adding substrate. I am adding substrate here. Just select the substrate, drag according to the distance of your transistors and place it this in between the blue and yellow line. You can place in between the blue and line. As well as you can take the device. This time the device type of name is NL for PMOS. Also the same thing you can take and move the blue and Now I want to make the connections by using a I-route. After substrates, I want to make the connections by using I-route. So the routing purpose, before routing, I want to place my input and output ports. So go to the in SDL Turbo, there is a pick and place ports. You can change the metal type as M1 in front of poly and take one by one node and place properly. Okay, then you can take reference and you can take almost all the things in place. So according to that, now I want to do out by using the rest of the thing. So you can click on the space bar, change the different metals. While you are pressing space bar, it will show the different metals. So I required only M1 present. This is my M1. Here also you can take the M1. So here I want to do you can press space bar, it will change the direction. So here some connections has been going to done. Change these two dimensions to some other positions, and you can move this one also according to your design. So this is your design. Later on again you can change another two things. Two things are in place. So for that I want to go for this middle one. Can go into, so I think empty is also doing there. I want to adjust something. First of all, I want to see this one. Okay, here it's fine. Now I want to change this one location to some distance of bound. It is possible right now. Have to type. So like this I change, right? So all my input is in one side and now my output is in other side, left and right. For the usage of the design, In future uses, I'm dot like this. Okay. So my layout has been completed right now without any hesitations. I cleared my layout. So after this, I want to go for add text on posts for giving the names. Click on add text on posts. This is the text on posts. This is options. And after saving these things, now you can go for verification. You can go for verification. Going to tools, caliper, run DRC. First case you can run DRC. So error. I can see all the things. Is there any error or not? For the DRC purpose. So still it is running to produce the yes, one error, that is polycity error. You can neglect this error. See, this is your poly density error. This is one. So we are not able to worry about this. Rest of the have been already checked. There is no errors still present. Okay. Right. Now, while you are closing your Calibri DRC verification, say every time is no, otherwise the previous things has been saved. Right. Now again tools, caliber, LVS, tools, caliber, LVS. Now click on run LVS. Yes. It is giving you a correct layout. There is no error existing in the layout. Both the schematic part and the has been same. If you are having any error, in the schematic part and layout part, then you can go for the schematic part of here in the verification point for this. Then you can open the individual netlist files like schematic netlist file and layout netlist file and identify what type of connection has been changed in your design. What type of connections has been changed in your design. So you can observe that in our design we can use only three only metals are two component M2 and use the metal coming in the body and the body. So it is only used to design this layout. Design the layout of my different amplifier. So parasitics, you want this is the parasitic format to caliber caliber and specs. Now what I want to do run price is already there. Export from I can click on enable export from schematic view. Go to the outputs in front of the DSPF. You can select Aldo in front of DSPF and ask resistance plus design specified parasitic format. DSPF means design specified parasitic format. Design specified parasitic this is your parasitic netlist file. This the entire file is nothing but parasitic file. So if you want doing
In the you can enable any parasitic like I can I reference input. So we are having resistor type 12, capacitor type as 8. So if I want to give my layout, so in this wire the resistance part is been existed. The wire resistance the resistance part is in existed. How much of percent of resistive part is existing? 0.047% of resistive part is there. Okay. So this is for layout point. Sir. Hello, sir. Hello, sir. Is anybody from the participants having any doubt at this time? Any queries from the participants? You can speak up. I am seeing someone here. From the participants. Hello, participants are there.
Vasu sir.
హలో ప్రదీప్ గారు.
Hello.
Hello.
Sir, any doubts? Doubts ఏమైనా ఉన్నాయా sir? Anybody
గారు.
having any doubts? Sir, ఏమైనా ఉన్నాయా sir?
అన్మ్యూట్ చేశాను సార్, అడగండి మనం.
For any doubts or clarifications? Participants?
Okay, Pradeep sir, no doubts I think. No one can ask.
Sir.
Paddu sir.
Tell me sir.
Sir, Paddu sir.
వాసు
డౌట్స్ ఏం లేవంట, ఇంకా క్లోజ్ చేసేసి చెప్పండి, నేను షేర్ చేస్తాను ఫీడ్బ్యాక్. ఫాము అటెండెన్స్ ఫామ్ షేర్ చేస్తాను, ఈ లోపు మీరు అది క్లోజ్ చేసి చెప్పండి సార్కి. థ్యాంక్స్ చెప్పండి, అవుట్ ఆఫ్ థ్యాంక్స్.
ఓకే. Dear participants, as there are no queries from your side, I tender my in-depth thanks to the resource person, today's resource person, Mr. Pradeep sir, for giving this hands-on experience to all the participants. Hope the participants will continue this learning process through this software as if it is available at their workplaces. Thank you, sir. Thank you very much. Sir, Pradeep sir, you
Sir.
can leave, sir. You can leave, sir. But participants will be there for the feedback.
Yes.
Thank you. Thank you, sir. Thank you very much.
Thank you.
Yeah, thank you.
And thank you participants, having a great day. Thank you.
సార్
సార్ రవి సార్
సార్ అది సెషన్ క్లోజ్ చేయొచ్చు అంటారా?
కాదు ఫీడ్బ్యాక్ ఫామ్ పూర్ణ సార్ పంపించలేదు 5 minutes పంపిస్తే షేర్ చేసిన తర్వాత పంపిద్దాం.
అంటే రికార్డింగ్ ఆఫ్ చేయమంటారా, సరిపోద్దా ఉంచమంటారా? ఇంకా
రికార్డింగ్ ఆఫ్ చేసేయండి. రికార్డింగ్ ఆఫ్ చేయండి.
రికార్డింగ్ ఆఫ్ చేయొచ్చు ఇక.
రికార్డింగ్ ఆఫ్ చేయండి.
ఓకే సార్.